Hey, good morning, folks. You're going to learn some new trick on how to analyze a data set using Python. It's really a cool problem. So let's dive into it. Okay, so I'm going to share my screen first. Um, so we're going to look at basically. Let me. Uh, okay, so here's my basic data set. Okay, so what we have here is time in minutes. Say or hour, whatever. Um, and data, concentration data as a function of time. So I have 10 minutes, 28 minutes, 46 minutes, 64 minutes, 82 minutes, 100 minutes, and I'm collecting data here, okay? And then my concentration changes from 95, 70, 50, 30, 20, and 15, okay? And now when I plotted it, this is how my data looks like. This is just the data, okay? Now, it turns out since the data has got a certain function, I know I can fit a model to it. And the model I want to fit is C as a function of time is C naught exponential minus KT, where C naught is a model parameter and K is another model parameter. In fact, C naught is known as max concentration and K is a reaction constant, okay? And so these two are parameters. Now, in Excel, you can do something interesting. You can actually generate your own time, which is 0 to 100 in a systematic fashion, and then create a model. Simply create an Excel spreadsheet, reading C naught from here, K from there, and I put a dollar to fix them. So this is basically this equation, C naught exponential KT. And then you plot it, and you can get the model. So this is my model, and this is my data. Guess what? It doesn't fit, right? It doesn't look close. So my initial guess does not look close. So what can we do? Well, I can do some trial and error. So what I can do is, let's say I made this, so it seems to be dropping pretty fast. So what if I said it's 0.1? Well, it's better. It definitely went up and it seems to be fitting kind of average. So I can do this trial and error. And since I know this problem, I roughly know exactly where the solution is. So let's say I put now 120 and 0.02 here. Well, voila, it fits pretty well, right? So you could do a trial and error solution and fit the data, okay? Now the question is, can I use Python to automatically do this, okay? Now, in order to do that, the first step we are going to do is we got to basically create this data. Python needs this data. So I'm going to copy this data into a separate file, and I'm going to call it as a CSV file. So this is my CSV file. So I copied here, and then I can save it as files, save as CSV, and I already saved it. So you can save it as a CSV file, okay? So I'm going to save this as a CSV file. And once I have done with that, now I can close this window and actually go to Python, okay? So here's my Python window, okay? So here, now I can actually look at how can I use Python to solve this problem, okay? And here's the code. So the code has got several components. The first thing I want to do is I want to import my NumPy and matplot, which you know. And the new thing I want to do is I'm going to do a SciPy optimize and import curvefit. Basically, here I'm actually importing this curvefit software into the system. Okay? And then I'm creating my function, this could be anything, which is the independent variable time, C, which is my constant, C max is my parameter, and K is my another parameter. And from that, I can calculate concentration is equal to C max NumPy exponential minus KT. So this is my function, okay? And once I have the function, then I start my main program, and then I create my input data. So my input data, I'm going to read my CSV file with the delimiter comma, and then I'm going to take the first column, which is the 0th column, into time, which I call TT, second column, which is my first column in Python, into data, which is basically my concentration data, okay? And once I have that, I'm pretty much ready to do the fitting. So in order to do the fitting, you always need an initial guess. So I'm going to guess the poor guess I already did, which is 80 and 0.1, okay? So that's my initial guess. And once I have the guess, now I can call the curvefit software. And in the curvefit software, what you do is you call it with my function, which is basically this function. And then TT is the independent variable, which is time, which is basically what you read here. And then data is your input data. So this is where you keep your data, okay? And remember, basically this TT has to match this essentially, right? So because that's the time you're interested. And the data is second one, and then P naught is equal to initial value. Initial value is one you initialized. Okay, so again, this could be anything, initial parameter or whatever. Okay, but you need to assign them to P naught. Okay, once you have that, that model will run and it will give you what we call a best values and covariance. Basically, best values are the fitted constants, and the covariance are the error associated with it. So fitted constant will be what is the correct value of C naught and K, and covariant is the error associated with these values. So you can print them. If you print the best values, you can print what are they. For example, in this run, I ran it and printed it, and you can see it came 118, which is very close to what we found, 120. And then the best K is 2.10⁻², which is 0.02. 002 which is what we found in our Excel. Okay, so basically that's what you're printing, and then you can also print the covariance matrix. That's the covariance matrix. I'm going to let you read about covariance matrix. It's got error information. In fact, this diagonal shows the error in the first parameter. This diagonal shows the error in the second parameter, and this shows how they are correlated essentially. I wanted to read about it. You can Google and read about covariance matrix and find error, and that could be going to be part of an exercise. So now that I know these values, I can now transfer the best fit value, the 0th value as my C max, which is the best one, and my first value into K fitted value. And then once again, I can call my same function to generate the fitted curve. Okay, why am I doing that? Well, let me first run this, and then I can explain. So this is what I want, right? So I have the data, I want the fitted model. Okay, so this is what I want. So in order to do that, I have data, which I can plot, which is basically, I'm plotting my data, plot TT and data. That is my data. And then I put a B naught, which is basically says, just plot the symbol alone. Don't connect them, okay? So that's my data plotting. But in order to plot this curve, I need to generate that. And that's what I'm doing here. Here, when I do conc my function, this thing, it basically generates an array of concentration by calling this function. Remember, I'm passing all arrays. So it automatically runs multiple times and updates this array. And then now I can plot TT and the conc, which is basically the fitted concentration. And that's what this is, okay? And then you do the labeling and then you're done, okay? So this is a very good software. And just to make sure you can see some of these things clearly, I also put them in Word file. And you can see, so just, basically to look at it, the key is again, this line, okay, curve fit. And here the my function has to match the my function. Okay, so I can draw that. So the my function and my function have to match. Oops, okay, let me erase this. The my function has to match that, and these parameters, basically these two parameters have to match here, okay? And these two are basically the data which actually comes from here, okay? So that's the only thing. And once you can do this, then you can fit any function. So that's it. Thank you.